Let's practice understanding the concept of opposites a little bit better together. In number 1, let's talk about what the opposite of a number represents. First, the opposite of a number represents a number with the same absolute value of the original number. Second, we can also think of the opposite of a number as the additive inverse partner for a given number. For example, to maybe make this a little bit more clear, if you take the number, say something like 7, the absolute value of 7 is going to equal 7 because it's 7 units away from 0. But you can also think that the absolute value of -7, which is the opposite of 7, that's also equal to 7, right? So 7 and -7 are opposites, but they have the same absolute value. So that's what that means right over here, right? Now for the additive inverse partner, that really just means what number do you add so we get 0. So if you take 7, right, the opposite of 7 would be -7. That's its partner, but whenever you add opposites, you always get 0. Okay, so that's what the additive inverse property talks about. If you have a negative number first, like say something like -3, and you go ahead and add a +3, right, that's its additive inverse partner, those are opposites, then -3 plus +3 also equals 0. So hopefully using these two examples, you know what opposites represent a little bit better. For number 2, let's carefully consider a few different pairs of opposite numbers. Then let's go ahead and see if we can conclude something about the distance between all opposite pairs of numbers. So let's go ahead and start off with maybe a few different pairs of opposite numbers. So maybe let's take the number 4 and let's use -4, right? So that would be a pair of opposites. Maybe we can see something like, I don't know, something like 3 and -3, those are opposites. Or maybe even something like, I don't know, 5.5 and -5.5, right? So these would be 3 different pairs of opposites. Now, if we go ahead and take a look at the distance between these things, right? If we look at this first example, then let's say we have a number line, we have 0 in the middle, we have -4 to the left, and we have +4 to the right. Well, the distance between -4 and +4 would be 8 units away, just because -4 is 4 away from 0, and then 4 is 4 away from 0, so the total distance would be 8 units, right? That would be how far the -4 and +4 are from each other. If you take a look at the second example here for -3 and +3, we have a number line, put 0 in the middle, we put 3 to the right and -3 to the left. You can see that -3 is 3 away from 0 and +3 is 3 away from 0. So it's a total of 6 units, right? So actually you can maybe see that we really just double the absolute value of each number. So the absolute value of 4 is 4, double 4 is 8. The absolute value of 3 is 3, double that, that's 6. And even if you take a look at something with fractions here, right? If we take a look at this on a number line, if we see where 0 is, +5.5 would be somewhere over here to the right. -5.5 would be somewhere here to the left. Now, how far away are these from each other? Well, this -5.5 is 5.5 from 0. This 5.5 is 5.5 from 0. So altogether, that would be 11 units apart from each other. Therefore, we can conclude that the distance between opposites is always double the absolute value of each number. So the absolute value of 4 here would just be 4. Double that, that's 8. Absolute value of -4 is still 4. Double that, you get 8. Same thing over here, whether you're taking the absolute value of -3 or +3, that's still 3, and you double it, you get 6. And the absolute value of 5.5 or -5.5 are both 5.5, and if you double 5.5, you get 11. So that hopefully checks out and makes more sense. For number 3, let's go ahead and see if we can go ahead and write the following verbal sentences as mathematical expressions. Then we're going to go ahead and simplify or simplify as we can. So for number 3, let's take a look. We have the opposite of 8. So the word opposite here means that we're going to throw on a negative. So the opposite of 8 is just really just -8, right? So that's all we can do for this one. For number 4, we have the opposite of -3. Now, how do we write that? Well, we put another negative on. This is the opposite of -3. So this would be a direct translation into a mathematical expression. And it says to simplify. So the opposite of 3, this is just equal to 3. All right, so number 4 could be simplified. If we say the opposite of the opposite, or the opposite of -3, that would be +3. For number 5, we have the opposite of 4.2. So here's the number 4.2. And if we want to say the opposite of it, just put a negative in front, right? That just means the opposite of 4.2, which would be -4.2. For number 6, we have the opposite of -4 and 2/3. So we take -4 and 2/3 and write it down, and we want to write the opposite of it, put this in parentheses, give it a hug, and put a negative in front, that means the opposite. So the opposite of negative 4 2/3 would just be a regular 4 2/3. Okay, next for number 7, we have the opposite of 7.4. So here's 7.4, right? Here's one of the opposites, and here's the other opposite. That's the opposite of 7.4, and the opposite of 7.4 is just equal to 7.4. Next, for number 8, we have the opposite of this negative 6.5. So here's negative 6 1/2. So we have to find the opposite of that, and then we have to take the opposite of that. So kind of interesting here, but we have the opposite of negative 6.5. Well, we can go ahead and say, well, that is going to end up being the opposite of 6.5 is going to be negative 6 1/2. Okay, so here's 6.5. If you take the opposite, it's negative. If you take the opposite of that, it becomes positive. If you take the opposite of that, it becomes negative again. So hopefully that makes sense. So let's take a look at this next section. We're going to go ahead and see if we can write the opposite of each rational number and then plot both values on a number line. So for number 1, we have the original number of 6, right? We're going to write the opposite of that. That's going to be negative 6. And now we're going to go ahead and plot both of these on a number line. So here's our number line. We can go ahead and put 0 somewhere in the middle here. Then we need to get to 6, right? So maybe I'll put a 3 over here and then a 6. Again, don't worry about putting every single number in between all these. Then we can put negative 3 and then negative 6 over here. So we're going to plot both of these. Then maybe we can put negative 6 down here to the left and put positive 6 over here to the right. Okay, so these would be opposites, and we can always go ahead and see that these are indeed the same distance from 0. So that would be 6 units, and that would be 6 units. Okay, for number 2, we have the number negative 3. Here's negative 3. What's the opposite of that? That would be positive 3. Okay, once we have that, let's go ahead and plot them so we can see where they look like on a graph. All right, on a number line here, I'm going to put 0 right in the middle. Going to 3 is not too bad, so maybe 1, 2, and 3. I'm going to put positive 3 to the right. I'm going to go 1, 2, and 3. I'll put negative 3 to the left here. So negative 3 would be over here to the left on the number line. Positive 3 would be over here to the right. We can see that this is 3 units away from 0, and this is also 3 units away from 0. All right, moving on to number 3. Okay, so we have the opposite of 14. So really this is just equal to 14, right? That's what the value of this one is. And if we go ahead and write the opposite of 14, that would be negative 14. Okay, so keep in mind that this negative 14, or the opposite of 14, is just equal to 14, and we should solve that first. All right, throwing this on a number line, let's put 0 in the middle here. I don't really want to go by 1, so let's go by 7, so we can go up to 14 pretty quickly. This over here would be negative 7 and then negative 14. Then we can go ahead and put a dot at negative 14 and a dot at positive 14. And we can see that negative 14 is 14 away from 0, and 14 is also 14 away from 0. For number 4, we have 0.25, so that's a quarter. So 0.25, and the opposite of positive 0.25 is going to be negative 0.25. On a number line here, we can put 0 right in the middle. Let's see, we're going to 0.25, so I don't know really what to go by here. It's a pretty small decimal. Maybe I'll say each of these is a nickel, or 0.05, so 0.05, 0.1, 0.15, 0.2, 0.25. So I'll say this is 0.25 over here. And I'll go negative a nickel, negative a dime, negative 0.15, negative 0.20, negative 0.25. Again, it doesn't really matter what you decide to do. Totally up to you in terms of what you skip count by, as long as you're consistent and you are detailed enough that it's easy enough to follow. Okay, so here we have both of these distances. Maybe I spaced them out a little bit more on the left side, but as long as you are trying to be consistent and as accurate as possible, I think that's what matters most here. Okay, so I could have spaced out a little better on the left side. All right, moving down to number 5, we have negative 0.75. So that's the original value here, right? And if we want to go ahead and write the opposite of that, the opposite of negative 0.75 is just going to be positive 0.75. In the middle here, I'm just going to put 0, and let's go by 0.25. So here's 0.25, here's 0.50, here's 0.75 over to the right. To the left here, let's say this is negative 0.25, negative 0.50, negative 0.75. In terms of what these are, here are the dots. And if we want to show their distance, this is 0.75 in the negative direction, this is 0.75 in the positive direction. For number 6, we have the opposite of 5.4. That's really just equal to 5.4. If we want to get the opposite of that, that's going to be negative 5.4. So again, just like earlier in another example, these two are exactly the same thing, just represented differently, so we just had to simplify it first. Putting this on a number line, let's go ahead and put 0 in the middle here. Let's see, I'm going to go maybe by, I guess I can go by ones here. So here's 1, 2, 3, 4, 5, and 6. And then I can go by ones here. So 1, 2, 3, 4, 5, and 6. So this would be negative 6 right over here. Okay, so where is 5.4 and negative 5.4? Well, 5.4 would be between 5 and 6, a little closer to 5. And then negative 5.4 would be in this direction, a little closer to negative 5 here. So this would be 5.4 units away from 0 on the negative side, and this would be 5.4 units away from 0 on the positive side. All right, moving on to number 7. For number 7, we have the opposite of 5.38. That's really the same thing as just 5.38 or 5 3800ths. The opposite of that is going to be negative 5.38. On a number line, let's go ahead and put 0 in the middle. Then I'll go maybe 2, then 4, then 6. And then I'll go in the negative direction, negative 2, negative 4, negative 6. Okay, so let's go ahead and see here. 5.38, so 2, 4, 5. That's going to be somewhere close-ish to 6, right? Because 5 would be halfway between. I went by 2s for each of these. Then let's see, negative 5.38 means it should be somewhere over here, closer to negative 6 than to negative 4 for sure. And if we're just showing the distance here, this is going to be 5.38 units, and this is also 5.38 units. For number 8, we have this fraction of 3/8. If we want to go ahead and write the opposite of 3/8, that's just going to be negative 3/8. Okay, and we can go ahead and plot these on a number line to see what they look like. Putting this on a number line, let's put 0 right in the middle. Let's do 1/8, 2/8, and 3/8 over to the right. And let's go maybe negative 1/8, negative 2/8, and negative 3/8 over to the left. Okay, I'm going to plot a point at each of these locations. And then if you see that this is going to be 3/8 units away from 0, this is also 3/8 units from 0. Moving on to number 9, we have a fraction, again, of negative 2/5. So it's the opposite of 2/5, which is negative 2/5. What the opposite of that would just be positive 2/5. Let's put it on the graph now. Let's go ahead and put 0 in the middle of this number line. Let's say maybe this is 1/5 and this will be 2/5 over to the right. To the left, let's make this negative 1/5 and then negative 2/5. So that would be to the left. Okay, so this would be 1 point, this would be a second point, and we can see that they are both equidistant from 0. That's 2/5 units, and that's 2/5 units. I think I might have spaced out a little bit too much on the left side again. I don't know why I keep doing that. For number 10, we have the opposite of negative 3.5, so that's the original value, negative 3 1/2. But the opposite of that, or the opposite of the opposite, would just be a regular 3.5. All right, now let's put this on a number line. We can go ahead and put 0 right in the middle. Then let's see, we have to go up to 3.5. So maybe this would be 1, this would be 2, this would be 3, this would be 4. So 4 would be all the way over here. So it would be negative 1, negative 2, negative 3, and negative 4 over to the left. So where's negative 3.5 and positive 3.5? So 3 would be there. So I think half, 3.5 would be pretty close to 4. And then negative 3.5 would be somewhere down here. I think that's a pretty good estimate. And so this would be negative 3.5, which is 3.5 units away. And this would be positive 3.5, which is 3.5 units away from 0. So there you have some different practice problems on looking at opposites and visualizing them. They should all have the same absolute value, which is their distance from 0. So hopefully you found this video helpful in understanding opposites a little bit better and how to plot them on a number line. And you also got a little better at making number lines and spacing things out as well. So as always, keep up the great work, and I'll see you in the next one.